Upon completion of this video, the inspector will have a basic understanding of how to test a retail computing scale. For training purposes, this video will focus on the most commonly seen 30 by .01 scale. The list of topics to be covered are as follows. Pre-test determinations. Under this category, we will discuss the following points: definition of a legal for trade scale, marking requirements for both marked and unmarked scales, suitability, position, and maintenance of equipment, scale divisions, and how to figure the total number of scale divisions for any scale, and tolerances. Under the testing procedure, we'll discuss the following topics: zero load balance, or how to zero the scale, applying test weights, which is also referred to as the increasing load test, shift test, decreasing load test, and zero load balance change. How do you know that the device you're testing is legal for trade? In order for a scale to be considered legal for trade, it must meet the guidelines set forth in NIST Handbook 44 and be approved by the National Type Evaluation Program. We'll cover some of those requirements in the next few slides. Scales that were manufactured on or after January 1, 1986 are required to be marked with an accuracy class designation. The majority of scales you'll see in the field will meet this requirement and be marked Class 3. Let's discuss some of the marking requirements for a 30 by .01 marked scale. First and foremost, always look for the manufacturer. If you don't see a manufacturer right away, it's probably a good bet the scale is not legal for trade. As you can see, this data plate is from a well-known manufacturer. As mentioned previously, if the scale you're testing was manufactured after January 1, 1986, then it must be marked with an accuracy class designation. The majority of scales you'll see in the field will be marked Class 3. Next, you need to look for the model and serial numbers. The serial number is a very important piece of information because it can be tracked. For instance, this particular scale could be moved to a different location or department within the same store, or it could be moved to a different store altogether. Having documented the serial number, the inspector will have record of the location of this scale at the time it was last inspected. And finally, look for the Certificate of Conformance, or CC number. This number signifies that the brand and model of scale you're testing meets the requirements set forth by NTEP, or the National Type Evaluation Program. Suitability of equipment. The scale you are testing must be suited for the service in which it's used with respect to the elements of its design. In other words, you wouldn't use a prescription or pharmacy scale to weigh produce, and conversely, you wouldn't use a produce scale for compounding in a pharmacy. Equipment must also be suitable for the environment in which it's used. Is the position of the scale free from wind or any weather that would adversely affect your readings? Is it free from any RFI interference such as two-way radios and cell phones? Position and maintenance. This point is very important because it's one that has to be dealt with on a consistent basis. Scales must be easily accessible and free from obstructions. It must also be level, stable, and free from maintenance issues. For example, are all the lights working correctly? Are any parts missing, such as a leveling leg? Is the level bubble cracked or broken and not usable? Also, scales must be maintained in a level condition at all times. Failure to do so can affect its readings. Not only does the scale have to be maintained in proper operating condition, but also any attached devices such as printers and labelers. Scales and any attached devices must also be kept clean and free of debris or anything that would cause a false reading or possibly compromise the integrity of your weights. Finally, and probably one of the most important points, the scale must be positioned so that its indicating elements or readouts are visible by the owner and the consumer. If it cannot be read accurately from a reasonable distance by both the owner and consumer, then that would constitute a violation and the scale would be rejected until corrective action was taken. Using Table 3 on page 2-20 in Handbook 44, you can determine the minimum and maximum scale divisions allowed for different accuracy classes. The example below is for a Class 3 scale. How do you calculate scale divisions? It's really pretty simple. Just take the scale capacity, 30 pounds, and divide it by the scale division, 0.01 pounds. That gives you a total of 3,000 scale divisions. This method works for any class scale you'll see in the field. The final pretest determination topic is tolerances. There are two types of tolerances, maintenance tolerance and acceptance tolerance. Maintenance tolerance is applied to scales that are in normal everyday use. This tolerance will be the most used tolerance by the inspector. If any of the following 5 conditions are met, then acceptance tolerance must be applied. A scale being placed into commercial use for the first time, a scale that's been placed into commercial service within the last 30 days and is being officially tested for the first time, a scale that's been returned to commercial service following official rejection or after being repaired and/or calibrated by a service company, a scale that is being officially tested for the first time within the last 30 days following a major reconditioning or overhaul, and finally, a scale that's undergoing type evaluation. Here we see the maintenance tolerances in Table 6 from Handbook 44. As you can see, the highlighted area shows the tolerances in scale divisions for Class 3 scales. Since we've already figured out our scale has 3,000 scale divisions, we can use this chart to figure our tolerances at certain increments or breakpoints. What this chart is saying is that from 0 to 500 scale divisions, the scale is allowed to be off by 1 scale division in either direction. To figure what the weight is at 500 scale divisions, you take 500 and multiply it by the scale division, 0.01 pounds. That gives you a weight of 5 pounds. So, from 501 to 2,000 scale divisions, or 5.01 pounds to 20 pounds, the scale can be off by 2 scale divisions. And finally, from 2001 to 4,000 scale divisions, or in this case, as we previously established, our scale has 3,000 scale divisions, the scale can be off by 3 divisions. If acceptance tolerance is applied, then tolerance in scale divisions will be 1/2 the maintenance tolerance values. As we get into the inspection process, you will find this table to be very useful in determining whether a scale passes or fails. Let's start the testing procedure. There is no set-in-stone procedure for testing digital computing scales. However, we'll be following the outline in EPO number 1 from Handbook 112. It's recommended that the criteria in this outline be followed as a minimum. Step number 1, zeroing the scale. In order for a scale to be legal for trade, it must be able to be zeroed. The majority of scales in the field nowadays are digital and are equipped with a push-button zero. Step number 2, check for zero load balance. After pressing the zero button, ensure the scale is reading all zeros prior to applying any test weights. Step number 3, increasing load test. According to EPO number 1, it is recommended that the first weight placed on the scale should be 20D, or 20 divisions. 20 divisions times 0.01 equals 0.2 pounds. The next weight placed on the scale is 0.5 pounds. Now check the scale at 1 pound increments to 5 pounds. Next, increase by 5-pound increments to 1/3 capacity, or in this case 10 pounds. Once you've reached 1/3 capacity, you'll need to perform a shift test. Mentally draw a cross on the platform of the scale so it's divided into 4 equal quadrants. Start by placing 10 pounds in the center of quadrant number 1 and continue that for all 4 quadrants. Make sure not to slide the weights across the platform, but rather lifting them up and placing them in each quadrant. Also, make sure to recheck the zero load balance, or that the scale returns to 0, each time the test load is removed from the platform. Continue with the increasing load test at 5-pound intervals to capacity. Also, make sure the weights are centered in the middle of the platform as much as possible. Next, begin the decreasing load test. This test is performed by removing weights so that you can test the scale at the tolerance breakpoints. Since you've already tested the scale at capacity, remove 10 pounds so that the scale is at the 2000 division or 20-pound tolerance breakpoint. Then remove 15 pounds and check the scale at the next tolerance breakpoint, which is 500 divisions or 5 pounds. And finally, once all of the weights have been removed, check the zero load balance change. There is a tolerance at 0, but the zero load balance shouldn't change by more than the minimum tolerance applied.